Hi everyone, welcome to this crash course on simple switches. So this video is going to cover how to use a very simple switch as a limiter or a trigger of some sort. So you have two of these switches in your kit of parts. They just look like these little guys. They have 3 pins, essentially because they work in 3 different modes. So there's a common pin where the switch current, I guess the electronic current will always go through, and then there's one path that will go through when the switch is not pressed, and then another path that will go through when the switch is pressed. So in our case, that's not terribly useful because you can always invert the logic to kind of your own liking. But for some applications, it actually is useful for power consumption or maybe a safety feature where the failure mode is important. So if we just look kind of quickly at the schematic, so the switch does have the C is common, so that's the pin that is most closest to where the switch hinges. And then, so that one over there. And then you've got it normally open. No does not mean no, it means normally open. And that means that the switch circuit is open normally. So when the switch is not pressed. And if you look over here, this part of the circuit is open. There's a gap here. That means current cannot go through here unless the plunger is pushed, which moves this bar down to here. So when you push the switch, that closes the circuit and you have current flow. And then the normally closed is the exact opposite. So when the switch is not pressed, so normally the current the circuit is closed, so the current flows. So if essentially if you're looking at your code and when you push it, it goes to 0, and when you let go, it goes to 1. If you want to reverse that behavior, you just attach your wire to the other pole. Of course, you can also reverse that behavior in your code to just say that when the switch is 0, that means that whatever. And when it's 1, it means something else. So you can easily choose what those somethings are. All right, so wiring this switch up is a little bit tricky in the sense that normally you would solder onto to these little pins. They're pretty tiny. As an alternative, if you don't have a soldering iron, you can just take these wires that you do have, those DuPont wires, and there's a little flap on here. If you pull that flap up with maybe a tweezer or something like that, and then you pull these terminals, the black caps off, you'll end up with these crimped ends. These are still kind of too big for this, like they're fairly loose, so they certainly won't hold. But you could just take a pair of pliers and essentially crush them on. So if you don't have any soldering, that's one option. And remember, you always have to have definitely one on this common, and then you can choose whether you do the normally open or normally closed terminal. I suspect the normally open is probably the more intuitive, so that when you hit this, then that closes the circuit. You can actually see C, NO, and NC. I doubt you see that on the camera, but you can read it on the switch. So that can help you. So let's assemble that onto a robot. All right, so it's a little hard to see, but essentially what I've done is I've connected the one side, the common, to a ground, and then the other side to the A0 pin, because I know that one's not currently in use. So it looks like that over here. So your common going to ground, and your A0 going up to the normally open pin of the switch. You could hook the pin up to power and have current flowing that way. There's a risk that way that you could burn out the terminal if you don't put a resistor in the circuit. So I'm going to show you an alternative that's probably a little safer. Um, so if we go into the code, that, and let's turn my robot on so it's powered when we get to programming it. So we go to code and we go to projects, project manager. We're going to add a new project. We're going to call this switch. Go back to code. All right, so we have this code in here, the demo code. I'm just going to go ahead and delete all that. and start from scratch. All right, so the first thing we need to do is define which pin we're on. So we're going to call this switch input. I put that on A0. And then we're going to do void setup. And we're going to do a serial.begin to open up the serial port so we can see what's going on at 115,200 bits per second. And then serial.print line. And we're going to say switch test v1. If you haven't heard before, I like to start my programs with something to know that the code I have running on the robot is actually the right code. And if I need to change something, I can change that to version 2 to make sure that version 2 actually gets into the robot. So I'm debugging not my firmware updates, but my actual code in case there was a failed update. Oops, loop, like that. All right, so essentially the switch is pretty easy, except that there's a bit of a trick to initializing the hardware. So normally we do pin mode for switch, oops, that one, and we would normally set it up as an input. But because right now, if I've got one section connected to ground, is the C, and I've got the other pin connected over here that I'm reading from. Well, if the circuit is open, I'm reading kind of unknown, but probably not a high. And then if it's closed, I'm reading ground. So it's really hard to tell, like you don't really get a 1 or a 0 from that. So what you can do instead is with Arduino and most microcontrollers, instead of just sending it to an input, you can set it to a input with a pull-up. So what that does is it connects the essentially connects the pin internally to a voltage high. So internally the pin will be pulled up to a 1 unless you ground it. Okay, so this may make the switch work in reverse, but we can get around that by changing our logic or by changing our hardware to connect to the normally closed pin instead of the normally open. So let's see what we get. So I'm gonna just do as a shortcut, all I care about here is to print the current value of the switch. So let's just print, and we're gonna read, digital read the switch input. Okay, so instead of assigning this to a variable and then printing out the variables, I'm just doing it in one step. You are free to do it either way. So now we should print this message, and then we should print this continuously. Now, I don't really want this to go too fast. Let's just do a delay of 100 milliseconds, so we're only doing it 10 times a second. We could even do it like 5 times a second if we wanted to, and that will kind of prevent us from overwhelming the serial port. All right, so let's select the port down here, and let's compile, make sure I didn't make any obvious typos. Good. And then I'm going to hit the compile and program. It's going to compile a second time, and then hopefully send it out. I believe if we get a protocol error, that's just a bug. We'll try again. And if not, we'll reset the robot. Takes a few seconds. There we go. All right, so now we're good. So now, if I, oops, close that. If I go to the monitor portion, all right, so it's telling me it's 1. So that was expected because we're pulling up high and we're not pushed, so it should be a 1, and it should be giving me that kind of 10 times a second. Let's bring up the camera view. So now when I push it, it should go to 0 if everything went well. Yes, 0, 1, 0, 1. Now if we wanted to, I don't recommend changing wiring while the circuit is live, but I'm going to do it anyways. I can take the risk. If I change it to here, now we're getting a 0 normally, except when sorry. Let's see if that, you should really crush these things or solder them, but we're gonna hack it for now. There you go. So touching the pins can also affect the value. So now it's 0, and if I push it, it's 1. So there you go, we're stable. 0, 1. Okay, so you can choose whether to reverse this logic by flipping the hardware. If it's easily accessible, that might be good to you. The other way to do it is to flip it in the software, and we can do that instead of doing it in here. We could just do something like maybe if the pin, and if we don't give any arguments, this is saying if the pin is true or high, then we want to say, so that's the way we have it right now. The switch is pressed, else not pressed. Okay, so it could be something as simple as that. Let's see if it'll go over and show. There we go. Monitor. Well, that's interesting in terms of print line. Oops, that's not what I wanted to do. Guess we're going to reprogram it. And one more time. Actually, if it didn't, let's just say the serial is there. I didn't actually want to program it. There you go. That is very interesting. There's a switch pressed and no switch pressed at the same time. Ah, now I lost my switch again. Make sure your hardware is stable or else you're just asking for trouble, like me. There you go, switch pressed, no switch pressed. And not entirely sure where that is messing up, but I'm sure there's a really good reason in terms of why the text is not right, not pressed. Serial print line. Yeah, not sure about that, but you get the general gist of it. So the key parts for this are just wire it the way you want to. And if you don't get what you want, you can just invert it in code. So now if we change the wiring, I could just put a not over here, and that would invert the logic so that if it's not high, it's switch pressed, or I could just change the text in here. So it's one way or the other, it would work for you. So hopefully this has been useful, and if you have any questions, post them to our Discord chat, and check out our other crash course electronics videos for working with other sensors and electronics. Thank you. As a quick appendix, I changed the code to just be dashes instead of the words there were. I reprogrammed it, and now it is working properly. So not sure why it messed up with that little glitch, but I reprogrammed it and it was fine. So there you go. That's it. Bye-bye.